Hello, everyone. Thanks so much for joining today's webinar. My name is David Krozak, and I am a Customer Success Manager here at Genuity. And our topic today is why MFA is no longer secure. And the speaker will be our Chief Information Security Officer, David Denali. Without further ado, I'll pass it over to David.
All right. Thanks, Dave. So I think I see a few people still joining. So I'm going to pause for just a minute. I see participants still pouring in, and then we're going to get started. Okay, I think the participant number has stayed steady, so we're going to get started. So thank you all for joining us. We're going to talk about, again, the fall of traditional protection. So as technology advances, so does the threat of cybercrime. So we're going to talk about the pitfalls of traditional multi-factor authentication and the need for ultimately layered defense. So let's get started. All right, so our current reality. Hackers are becoming more sophisticated and conjuring up new ways to hijack your system by exploiting technical vulnerabilities or human nature. This was a quote by Kevin Mitnick. He was the chief hacking officer for KnowBe4. Very interesting gentleman, just passed away recently, very sad. But I did a book report on this gentleman in 8th grade on hacking. So if you want to find some cool information, look up Kevin Mitnick. So our current threat landscape. So company Cybersecurity Ventures just created a report that broke down the various loss estimates for global IT. So they predicted that global cybercrime damage costs will grow by 15% year over year the next 3 years, reaching $10.5 trillion annually by 2025, up from $3 trillion in 2015. So these financial losses are reaching staggering figures. And as we've talked about, trillions of dollars being lost. So the estimated losses for 2023, we have $8 trillion estimated to be lost this year, which equals $667 billion a month, $154 billion a week, $21.9 billion lost a day. So again, these numbers are staggering and they've only grown over the years. I mean, as they had just talked about in the last 10 years, it's grown by $7 trillion and it's not looking to slow down. So as we're going to talk about, ultimately, there's no silver bullet that can completely protect you against all attacks. Okay. We're going to talk about phishing resistant MFA and how that can completely secure the authentication process. But we're going to also talk about some additional security mechanisms to protect you as a whole. So how do we decide what controls we want to implement on our organization? What's our roadmap? Where do we get this? So we want to develop a security program, okay? So these programs comprise several key elements, okay? We have a security framework to guide the establishment of controls. We have detailed policies and procedures for compliance. We have thorough training for effective implementation, and we have technology to support all of these measures. At the top, the program is governed by governance, risk, and compliance processes, which ensure continuous oversight and adaptation in the face of ever-evolving risks. And this life cycle involves regular updating, monitoring, assessment, testing, and reporting to maintain a strong defensive posture. So as we can see over on the right, we have our framework as the base, supported by policies, training, technology, and GRC. And this is a continuous process. So we're able to gauge the security maturity of an organization. So looking at this model, many organizations are on the reactive side. So they're doing what's called blocking and tackling. Okay. They have a lack of executive support. They could be underfunded, understaffed. They may have lack of metrics for reporting. Essentially, they're set up for failure. As we move to a more proactive approach, we want to be compliance driven. So we want to have control-based security approach that aligns to potential mandatory regulations like PCI, HIPAA, ISO. And eventually we want to move into a risk-based approach, which is a multi-layer security and risk-based approach using behavior analytics, which evaluates new technologies frequently, should be constantly. And we're going to want to link events across multiple disciplines. So ultimately, that's going to lend itself on the technology side to implementing a SIM. So that's our single pane of glass for ingesting and correlating multiple sources of data. All right, so why we're here. We're going to talk about first what I call legacy multi-factor authentication. So we have mobile application push notification, and here's the key, without number matching. Okay, so we get a push notification on our phone. We don't really have any context. We hit OK, and the connection is established. The other side of this is SMS or voice. So with SMS, you get a text-based notification. With voice, a system calls you, you hit a certain number, and that completes the multi-factor authentication process. Moving up a little more modern than that, we have our apps that are generating our one-time passwords. Okay. We also have our mobile apps that are doing mobile push notifications. And this is key with number matching. Okay. And we also have our token-based one-time password devices, which they all fall under the same traditional multi-factor authentication, which, as we're going to show in the video shortly, can be compromised very, very easily. So when I've been testing the attack that we're going to show you, I tested this against various systems. So I went out, I contacted a few full proxying services that offered web browser sandboxing. Um, I was able to use my link. I was able to get to the authentication process and complete it. So that didn't stop my attack. I tried DNS filtering products, didn't stop the attack. Next-gen antivirus didn't stop the attack. And ultimately, the Microsoft Authenticator push with number matching, and it got right past that as well. So we're now going to dive into the demo, and this is going to illustrate how easy it is to capture multi-factor authentication using these traditional methods. Just give me 1 second and we're going to get started. Oh, and apologies, bear with me. And let me jump back over to here. Okay, let's see if we can get audio with this. All right, so we've logged in my Linux virtual machine. We're going to load up the EvilGenix 3 application and a couple different fishlets. So once we have the utility loaded, we're going to set a few configuration values. So give me just a second to copy these values into the terminal. All right, so what have we configured? We've configured our attack domain. We've configured the external IP address of our server. Although for the purpose of this demo, I was able to get it working in my internal lab environment, which is why you see an internal IP. Okay, we will load the fishlet that we're going to be using. So in this case, we're loading the Office 365 attack fishlet. And a fishlet is a small configuration file used to configure EvilGenX for targeting specific websites. There are fishlets created for just about every major service. So now that we've loaded our fishlet, we're going to enable it. The fishlet slash application will now reach out and retrieve 11 valid certificates to use with the module. Notice with this utility, we aren't copying any websites like previous attack applications. We are acting as a proxy for the various services. So we've created our lure, which is essentially our attack URL. And we're now going to retrieve that URL that we're going to use on our attack E machine. So give me 1 second. We're going to flip over to our Windows 10 workstation, and we're going to try to log in with my account that has MFA with number matching. Okay, now that we've switched over to our Windows 10 machine, we're going to copy in our attack URL. We're going to log in with our test account. Okay, we've gotten the MFA prompt on our phone. We're going to type in the number that we see on our screen. Got 37. We're going to click yes. You're now logged into the 365 service. The best part of this attack is, unless the user is looking at their toolbar, they won't even notice that essentially they've been hacked. So as you can see, the URL is my attack domain name. I'll move up there. And yet all the 365 services will be operating normally because again, this acts as a proxy. So if I had any Office 365 applications here, I'd be able to load them and use them just like normal. And I close the screen and go on my merry way and think that I was perfectly safe. So we're now going to flip back to the attack machine and see if we were able to capture essentially the credentials that we just used, the authentication token, and create a cookie. Okay, so we've switched back to our attack machine. We can see in the log we were able to successfully intercept all tokens. And if we want to see further proof of that, we can type sessions to see the captured information. And if we want to go a little deeper than that, we can go to session. And we can actually see the captured cookie authentication information. So we can use this cookie information with various utilities to generate access, refresh tokens, exfiltrate data, etc. And refresh tokens only expire after 90 days. So if you want to contact us after the main presentation finishes, we can discuss ways to reclaim a compromised account as it now goes beyond resetting a password and enabling MFA. So now we're going to switch back to the main presentation and wrap everything up. All right. Now to follow my previous notes, additionally, because my attack domain had been registered for years, every service that we tested it against, marked it as a valid domain because it had been around for 20 years and hadn't been used maliciously. The other side of it is the nature of the attack being a proxy. You're not trying to bring down any piece of malware. So our DNS filtering service, etc., thinks it's valid traffic because there are many valid uses for proxies. So we were able to bypass all the protection mechanisms, basically short of using phishing resistant MFA or implementing some of Azure's advanced features like Entra ID registering, joining a device, as well as registering it in Intune and supporting it with conditional access policies, which we're going to talk about in a second. So we're going to talk about phishing resistant MFA being the gold standard. So if you do a search for phishing resistant MFA, you'll probably come up with a graphic from CISA, and it's going to show on the left side FIDO authentication / web auth n, and on the right side, you're going to see PKI. So FIDO2 authentication essentially is the global standard based on public key cryptography. And the key feature of this is that FIDO authentication, beyond using phishing resistant credentials, allows a user to essentially fulfill both factors of authentication through the process, meaning you can start doing passwordless sign-in. So if we wanted to go to 365, we could put in our username. We could click sign in using an external device. I would touch my security key. I would enter my PIN. I would touch my security key one more time. And then again, without a password, be signed right into the service. Now, WebAuthn is a subset of the FIDO2 authentication protocol. Okay, so it's the latest version of their open authentication standard, and it also supports passwordless authentication. And this is supporting it in our web browsers. So this is allowing us to use our security keys in a web browser for our, sign in. Now, with PKI, we're looking at certificate-based authentication, which works by granting the application the ability to validate and verify the identity of a user based on proof of identity through these trusted digital certificates. Okay, and digital certificates function as electronic passwords or files. They identify an entity trying to gain access to a resource using cryptography, and most banking applications use CBA. One additional thing is I see a lot of large organizations that don't want to roll out hardware security keys, moving towards CBA. So on the next slide, we're going to see what are some ways, or what are some mechanisms that we can enable phishing resistant MFA. So we have our FIDO security keys. So we have our YubiKey. We have a new Google Titan security key. We have a YubiKey Nano. So how these operate is essentially like I was telling you before. Put in your username. You don't have to put in a password. You can essentially touch the button on the key. It's then going to ask you for your PIN. It's then going to tell you to touch the button one more time, and that's going to log you into the service. So that proves that it's something you know with the PIN, and it's something you have by touching the key. All right. Now, PKI based, Microsoft has come out with their Entra ID certificate based authentication, which is great. And, for larger organizations that don't want to potentially pay for security keys, it may be right up their alley. So the problem with Entra ID CBA, at least right now, is you need an external PKI. Okay. So Microsoft has talked about using Azure AD Directory Services, which is now Entra ID Directory Services, I guess. And you could theoretically spin up a certificate server. Let me tell you, the process is not good. It doesn't ultimately work. The best way to implement it is contracting with a third-party provider like SecureW2. This is going to allow us to then use our PIV cards, our CIC, our CAC cards for authentication. All right. As we talked about, Microsoft also has its own attack protection, although it's not the easiest to roll out. Why? Because you need all of these factors. So your device needs to be enrolled in Entra ID, either joined or registered. It also needs to be enrolled in Intune. And then we have to have conditional access policies to support all of this. When all of those are in place and you launch the EvilGenix attack like we just did, what's going to happen is the user's still going to be able to put in, theoretically, if they are using a username and password on top of a key, or sorry, they are using their username and password, but they'll put in their username and password. They will essentially, at that point, instead of getting prompted for their MFA, they will get an alert message like this that basically says, you can't get there from here, your device isn't compliant, et cetera, et cetera. So again, all of this is based on device compliance. And if you're going through a proxy service, Microsoft device compliance detects that and won't ask for the second factor of authentication. So it automatically breaks that whole attack process. So a few final points to wrap all this up. Just because we have phishing resistant MFA does not mean we are unphishable. Seems like an obvious point, but it's one that, all the security people make. So phishing resistant MFA protects the authentication process. So this protects us logging into 365. But what can also happen? I mean, we can get malicious phishing emails that could then be opened, load a Trojan, compromise our workstation, et cetera, et cetera. So this is why we need what's called layered defense. Okay. So with layered defense, and as we previously talked about, we have our spear phishing attack that went to a dock attachment, launched enable VBA macro, dropped the payload, sent out the remote access Trojan, did the command and control. So the way to block that off is to take advantage of these various security mechanisms. So optimally, we should all have an email security gateway. Okay, and we've got a few different examples, Avanan Proofpoint. We want to have DNS or full proxy filtering. So we've got Cisco Umbrella, we've got DNS Filter, there's some other providers out there. These are obviously not comprehensive lists. We want to have EDR, XDR, MDR, next-gen antivirus, okay, to stop these emerging next-gen threats. We have Sophos, Carbon Black, Sentinel-1. We want to have a SIM or a SOAR. So what a SIM is going to do is take the information from all these various systems, from Avanan, from Umbrella, from Sophos, from KnowBe4, from Office 365, from your network, from your firewalls. Essentially, anything you can feed into it, it's going to take that data, it's going to correlate, and optimally, it's only going to show you pertinent alerts for the different products. So instead of having to log into Umbrella or Avanan or Sophos to check out an alert, you can log into your Alien Vault, your single pane of glass, and look at your whole organization. And then we have our social engineering training. We can't forget about the end user. They are probably our most targeted, our riskiest people. And we partner with KnowBe4. There are a few other products out there, but we found them to be the best that we've seen around. So if you would like to dive deeper into any of the topics covered today, please reach out to success@gogenuity.com to schedule a call with our security team. And thank you all for joining us.
Thanks so much, David. Yeah, as David mentioned, you can reach out to success@gogenuity.com with any questions. We'd always be happy to help with any security initiatives. And I hope everyone has a great afternoon. Thanks again.
All right. Thanks, everybody. Thanks for your time today.